let's see what are isomers. So these two, they are isomers of each other. Let's write the molecular formula. Molecular formula, you just need to count how many there are. So carbon. So 1, 2, 3, 4, 5, 6 carbon. So C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogen. Let's count this one now. 1, 2, 3, 4, 5, 6. 6 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogen. So 14 hydrogen, they have the same molecular formula. So what's an isomer? So these two, they are isomers. They have the same molecular formula, but they have the different arrangement in space. If you look at this molecule and this molecule, the atoms are arranged differently in space. In this one, you see that CH3 is bonded on top, and in this one, there is no CH3 bonded on top. We call this branched. This is branched. This is a branch. So here it's a branched molecule. Here it's not a branched molecule. This is a linear molecule. Linear. Okay? So what are isomers? So isomers have the same molecular formula but different arrangement of atoms in space. Okay? So first example, you have to draw the isomers of these alkanes. So C4H10. So let's draw the isomers. So we're going to use the tip, count the number of carbon atom in the longest chain. So we're going to vary the number of carbons in the longest chain. 4 carbons, so let's start with 4 carbons. 1, 2, 3, 4. We'll fill in the hydrogen later. Okay. Then let's try 3. 1, 2, 3. So because there's 4 carbon, I need to include 1. So I'm including 1 at the bottom. Okay, and then let's try for 2 carbons. But if I draw something like this is the same as this one. They are the same because you see the carbons are linked in the same way. First carbon is linked to second carbon is linked to third carbon, which is linked to the fourth carbon. So which is the same. First to second, second to third, third to fourth. So it's the same. So this is not an isomer. So we have 4 carbon, 3 carbon. And that's it. Anything else will be the same as these two. If you can figure out something that's different, just let me know. Okay, so then you fill in with H's. Okay, this should go away. Right? So you see they have the same molecular formula. They all have 4 carbons and 10 hydrogen, but they have different arrangement in space. So that's 1 and that's the second, and they are both alkanes. So you're going to try for this one. You're going to draw that in your copybook, and then you're going to take a picture of it and upload it in the assignment. Okay? So try to draw as many isotopes as you can for C5H12. Make sure that the structures are not equivalent to each other's. Okay. So isomers have the same chemical properties, meaning that they will undergo the same type of reactions, but they have different physical properties like boiling points. So physical properties, these are the physical properties of alkanes: insoluble in water, less dense than water, so it's going to float, and they are flammable. That's why we use methane as a fuel, because it's flammable. And the physical properties change gradually as the molecular size increase. So melting point and boiling point, viscosity and flammability.